Parametric statistical test versus non-parametric statistical test. Parametric tests are basically used to make inferences about population, and for parametric test we take assumptions and we also take information about the characteristic of population, whereas it is not an important condition for non-parametric statistical test. Non-parametric tests do not assume that population have any characteristic structure. Parametric tests are most widely used in the researches. For example, in the marketing researches, in the medical researches, when we have a small data set, a small sample size, then non-parametric tests are mostly used. Because in parametric test we need a large sample size, we need random sample, as well as we need to come about the characteristic of the population. The main difference between non-parametric and parametric tests that non-parametric tests do not require normally distributed data. That's why they are also called distribution-free tests. Whereas normally distributed data is an important condition for parametric statistical tests. Non-parametric tests are less powerful than parametric tests. What does it mean when we say powerful? Powerful means when test can detect any change in the sample or the groups accurately. Non-parametric tests can perform on nominal and ordinal data, while parametric tests require interval or ratio data, also called scale variables. In some conditions, if we have data in nominal or ordinal scale, and nominal scale means when we use numbers only to name the variable or to name the subject's performance. For example, as we have classes like BS1, BS2, BS3 and BS4. So this 1, 2, 3 with the number has been given is only just to make sure that these are the junior to higher ranks. BS1 is the most junior class, then BS2, then BS3 and then BS4. So when only number is assigned, when we say group 1, group 2, group 3 without any considering any characteristics, so it is nominal. It is nominal. But when, as I gave you the example of BS1, BS2, BS3, these are the classes from junior to senior. So it is ordinal data. If we have our data in such rank order or in median values, then we use non-parametric test. Whereas for parametric test, we required interval or ratio data, also called scale variables. The psychological tests we use to perform researches, they are an example of interval data. The scores we get from there, they are in interval mostly. So if we have all the variables in interval scale or on ratio scale, then we prefer to use parametric test. But if one of the variable is in nominal or ordinal data, then non-parametric test can be used. In Parametric test, subjects not necessarily selected randomly, while for parametric test, samples should be selected randomly. Randomization is an important step in parametric test, while it is not an important condition in non-parametric statistics. Similarly, variability is not an important concern in non-parametric uh, tests. Non-parametric tests assess through group medians, while in parametric tests we use mostly mean, which is a measure of central tendency. Median is also a measure of central tendency, but when we work with parametric test, we need mean, but in the non-parametric test, we can use median also. Parametric test analysis provide more reliable results even if data is skewed as compared to non-parametric test. If we have some skewness in the data, if data is skewed towards right or towards left, then the results of the parametric test even more reliable than non-parametric. Non-parametric test does not require large samples. They can be performed on small sample sizes, whereas in parametric test we need large sample sizes. Non-parametric tests do not affect by the outliers, whereas in parametric test, as you know, that in ANOVA and in regression, as we have discussed, that there are the outliers should be dealt before running the analysis. So in non-parametric there is no such requirement. Now these are the equivalent pairs of parametric and non-parametric test. These are the some examples of parametric tests, like one sample t-test, like two sample t-test or independent sample t-test, one-way ANOVA. And equivalent to these tests, non-parametric tests available are one sample sign test, one sample Wilcoxon test, against two sample t-test or independent sample t-test. We have non-parametric equivalent technique is Mann-Whitney test. In parametric test, as we have one-way ANOVA, but if data is not meeting the criteria, is not meeting the assumptions of the one-way ANOVA parametric test, then we have the non-parametric available tests are Puskal-Wallace and Moore's median. Hypothesis testing, all the analysis we perform, it is basically to test the hypothesis. Whether we perform parametric analysis or whether we are using non-parametric statistical test, hypotheses are always formulated. In the parametric, when we use parametric test, one sample is a condition and sometimes we have two different independent samples. With one sample in parametric testing, we have t-test and z-test. With two samples, we have independent sample and paired sample, and the methods are two-group t-test or paired t-test and z-test. In non-parametric statistical analysis, for hypothesis testing, if we have one sample, then we can use chi-square or Kolmogorov-Smirnov test. But if we have two samples, independent sample, then we can use chi-square and Mann-Whitney. If we have paired sample, then we can use sign test and Wilcoxon chi-square test. Independent sample means, I want to make it clear here, independent sample means two different samples. And paired sample means two samples, but it is a pre-test post-test type condition that we take test, a pre-test from a group of, for example, students. We apply a teaching technique. We take a pre-test from them before applying the teaching technique. Then we apply a new teaching method and we check their learning for 1 month, for 15 days, or for 6 to 8 weeks. And then after completing the new technique, we take their result, we take another test from the same sample. So it is called pair sample. Sample is the same before and after. Before applying a new teaching method, what was their learning? And after applying a new teaching method, we take another test from the same sample and we check, we compare their performance before applying new teaching method and after applying new teaching method. So it is called pair sample. We get two set of scores, but these two set of scores from the same sample. Thank you. I hope that it will be clear to you all.